Good afternoon, everyone. I welcome you all once again. We are having one more session, and let me introduce Dr. Iqra Altaf Gilani, presently as Assistant Professor in the Department of Information Technology, and he will be taking this session further, adding some more information or expertise in the information of in the application, real time applications in IoT and 5G based networks. So I welcome ma'am, please join.
Thank you so much for your kind introduction. Good afternoon, everyone. So let me share my screen. All right, so is my screen visible?
Yes, it is visible.
Okay. Okay, so once again, good afternoon, everyone. So I am Iqra Gilani, as already introduced. So I'll be giving a session on a talk on industrial Internet of Things and 5G. Okay, so just a disclaimer, my talk is not going to be about, very technically heavy on content. I'm not going to introduce you to different standards and technologies. The aim of my talk is more of an awareness talk. Okay, and by awareness, what I mean is I want you all to be aware of this concept, what is called industrial IoT or industrial Internet of Things, and how 5G impacts it. And the main idea is to make you aware of how you can actually consider the use cases in and around your vicinity, in your local industrial environment, the place where you come from, so that you can take the cues whether the IIoT or industrial IoT, Internet of Things can be applicable in the domain where you are currently residing, right? That's the aim of the talk. That's the goal of the talk. And with that goal, let's start with our talk. So as you can see, the topic of the talk is industrial Internet of Things and 5G. So there are two key phrases as part of this talk, right? So there is industrial Internet of Things and 5G. Okay, and as I'm sure a lot of my colleagues might have already given a lot of information about Internet of Things, 5G, and so on. Okay, but to give the overall context, I'll be going again in a very brief manner through what is IoT and what is 5G. So let us start with the first things first, which is what is IoT. So what is Internet of Things, right? So I'm sure all of you might have already known what is Internet of Things, and from this workshop itself, you'll have got a better idea what it's all about, right? I would prefer this talk to be interactive. At any point of time you have any questions, please feel free to interrupt me. So let us see what is Internet of Things. Okay, so Internet of Things, if you can see, if I want to summarize just from the picture I can see on the screen, there are again two words associated there, Internet and Things, right? So when I talk about Internet of Things, what do I mean? Okay, if I just go by the name itself of Internet of Things, these two things will give you the essence of this concept itself. Okay, so we have things, okay, and what we have is Internet. So what we do in Internet of Things is basically we deal with a collection of objects or things, and we want to connect them in a way the internet is connected. Okay, we all know the internet is currently what connects all of us. You know, you are sitting here in India and you want to connect to someone in US, you can just be connected in a jiffy, right? How is that possible? Because of the connectivity provided by the internet, right? So now what is Internet of Things? Internet of Things is exactly the same concept, but extended to things, objects. So far, when we talked about internet, we talked about communicating or extending communication among the people, among the persons involved in a society. But now we are extending the concept of internet to things also, the objects, right? So Internet of Things is nothing but a collection of objects which are going to be connected in form of an internet. That is, we're going to communicate with each other and transfer the information. Okay, like you can see from the figure, we can see there's a home in the middle of the picture. And then there are different kinds of devices which we normally have at home. There's a CCTV, there's a washing machine, there's a refrigerator, and there are the electricities all going on around. And you can see all of these are sending data, and you can access all of them using a single click of your app, right? That's the essence of Internet of Things. All these objects, which like a decade back had no significance other than what the job they did, now have an added meaning to them. What is that added meaning? We're going to give them unique identifiers, and we are going to connect them so that they can send and exchange their data among themselves, as well as convey that to some processing unit. Okay, and we as users can access that data through our simple user interfaces, right? So that is like this picture completely summarizes, although this picture specifically is of a one use case where we are going for home automation or smart homes, but in general, what we aim in Internet of Things is the same idea, that we are going to connect all different kinds of objects with unique IDs so that they can communicate with each other, right? Now, if I go by the progression of how IoT developed, this was first coined by someone called Kevin Ashton, who was in Procter and Gamble's, currently in MIT. And the way IoT began was using RFID technology. So the idea where IoT began was to keep track of the things. Okay, you want to just keep track of things where they are going on. That's where IoT began, right? But nowadays, it's no longer just tracking, and not just of objects, right? Like you can see the heading of my slide, it's now connecting everything to everything. There's no such limitations which have been defined by IoT nowadays. Okay, you can have any sort of device, you can have any sort of business, any sort of service, any sort of underlying networking technology. You can be at any place communicating with anyone. Okay, that's what summarizes Internet of Things. The whole idea is you consider a collection of bunch of different devices, okay, associated with you, associated with your friend, associated with any member of your society, and the ability to connect all of them and exchange all of them so that you achieve some purpose is what is your Internet of Things, right? That's like a very high level overview idea of what IoT is all about. It's just giving unique identity to those dumb devices which like a decade back had no other use than the means for which they were made. Now we are making them intelligent. You know, the term we use, we are making them smart devices. How do we make them smart? First thing is giving them some unique IDs, and second thing is enabling them connectivity. Okay, so if I kind of summarize what are the two things which essentially make IoT important, first is you give them unique identification. Okay, you give them some unique ID, and then you network them up. Okay, that means after I give them unique ID, I allow them to communicate or network with each other. Okay, and you can see the dependence between the two. If I don't give them unique ID, it's not possible to network them. It just logically follows, because if in a network I don't have unique IDs of different devices participating in, how am I going to address to each one of them, right? So IoT, like in a very overview perspective, is all about that. You connect collection of different objects in a network structure and allow communication through and through, right? So that's not my topic, so let me just jump in through that. So that was IoT, right? Just an overview idea of what IoT is about. Okay, now coming to our prime topic, which is industrial IoT or industrial Internet of Things, right? Now all of those in the audience, even if you have not ever heard about this term, you might have already guessed what it will be all about. You know, it's just combining some industry stuff with IoT, right? Exactly. If this is your thought, that's what it is all about. It's extending Internet of Things to industry, right? So before I, formally take up what is IIoT or industrial Internet of Things, first thing we see, the new thing which is coming in the slide on the picture that you can see is the word industry, right? Because IoT, we already saw what are the key ideas in IoT. But what is industry, or how is industry being connected to Internet of Things? Let's have first look at that. Okay, so if I talk about industry, okay, like from our high school itself, in our history books, we have studied industrial revolution, right? Industry has proliferated over the past decades tremendously. Okay, and If you look at this slide, which basically tells you what has been the evolution of industry, so there has been 4 major generations over the period of time when the industrial revolution started. Okay, from 1.0 to 4.0, we have progressed a lot. Okay, if I kind of summarize what has been the highlights of each kind of genre of this entire evolution. So we started in 1784 when actually we formally used this term called industrial revolution took place, when actually the normal machines which were not actually machines at that time, we used to manually operate them, they started to get mechanized, right? And the main power which was thrusting that mechanization was steam power. And we saw that it brought immense change in the society. But eventually in 1870, we moved to industry 2.0, which was basically when we started going for mass production. By mass production, I mean, I'm not concerned about generating stuff in for, 10, 20 people, but I want to generate it for masses. So if I want to go for masses, I can no longer rely on small mechanized machines. I need to think big, right? And that's where assembly line came into picture. And assembly line, you can logically see, cannot be supported just by steam power, right? You cannot support a huge factory just by steam power. That would involve so much of resources in terms of water, as well as the fossil fuels you burn, right? So the thrusting power which boosted industry 2.0 was your electrical energy, right? And that's how we kept on progressing, and we moved to industry 3.0, which is something what we have been seeing in past decade or so, which actually came with the development of computers and electronics, where all of the machines got automated, right? And this, again, all these evolutions had a backend, some backend technology which boosted it. So industry 3.0 was all about computers and electronics, the development of the large-scale integration of chips, and that is what led us to industry 3.0. Now, what we are interested in for this talk and for the industrial setup in today's world is industry 4.0. Okay, what is industry 4.0? It is something which is going to use these technologies like IoT, combination of cyber physical systems, and many more technologies. Right? So this is what we had, the evolution of industry from 1.0 to 4.0. So as I said, my interest and the interest of this talk, all of you audience, is on industry 4.0 because this is what is relevant to us. So let us now little bit elaborate on what all components are there in industry 4.0. So industry 4.0, as you can see, industrial IoT is one of its components. Okay, so what is industrial IoT? I've not yet opened up, but you can see it's part of industrial revolution. Okay, industry 4.0 came into the picture because of industrial IoT. Okay, so it's something which is going to give more meaning over industry 3.0. That means it's no longer just automation. Okay, so you can see from this slide, I just highlight it here, automation is already a part, and we already know it was there in 3.0, right? So what new thing is industry 4.0 bringing in? Okay, the new things which industry 4.0 is bringing in is the use of different kinds of things like sensors, monitoring tools, quality check, various use of apps, extreme use of network centric tools. Okay, all of this is engulfed in this term industrial IoT as well as individual components. Okay, and what do you aim to do? The basic aim is to reduce the intervention of humans. That was the idea of industry 4.0. To increase the throughput, obviously, that's how the evolutions progress. If you move from 1.0 to 2.0 to 3.0 or 4.0, your aim is always to progress, to increase the throughput, right? And what was observed was one of the major bottlenecks when we deal with the industry production is the human labor. So that is where the motivation came from industry 4.0, that what you need to do, you want to reduce the human intervention to the extent possible. You cannot ignore it completely, right? But you need to reduce the human intervention to the least possible extent. And that is where industrial IoT kicked in. Okay, that is where the motivation of industrial IoT came into picture. Okay, and we'll formally see what is industrial IoT now, but this is the overall picture. Industry 4.0 is what led to what was the birth of industry 4.0 came with the idea of industrial IoT. And what was the aim? Reduce the human intervention to the extent possible. And why so? Because that is where our bottleneck lies. So let us proceed further. So this picture can give you an idea of where IIoT is placed. It sits in the middle of your Internet of Things and Industry 4. Okay, so what if you understand this Venn diagram that you can see on the screen, it makes all the sense that you need to know for the understanding IIoT. IIoT has the has the components of Internet of Things, okay, which means the basic principles that you're going to use are going to be of IoT. But what is the use case where you are going to implement them? That is your Industry 4.0. Okay, and that's how you can see that IIoT sits exactly in the middle of these two things, Industry 4.0 and Internet of Things. Okay. Now, before I kind of go ahead, formally defining IIoT, any questions till the motivation part? If you have any questions, you can unmute yourself and answer, or you can drop in the chat box. I'll request Jahangir sir to tell me if there are any questions.
Sure.
Please, I request everyone to please be interactive. I'll prefer to have this talk more of a dialogue than a monologue. Okay, so I assume so far there have been no questions, so I'll continue. So what is industrial IoT or industrial Internet of Things? Let's look at the formal so-called definition of it. The industrial Internet of Things is basically use of smart sensors and actuators to enhance manufacturing and industrial processes. Okay, so you can see I've just tried to use some technical definitions, but we already had an idea of what it is all about. Okay, so let me just break down the sentences that we have seen. It's use of smart sensors and actuators. I'm sure everyone, like the audience, quite is familiar what sensors and actuators are for, right? You need to get input from your surroundings. You need to gather data from your surroundings. That's what we are talking about. So the input or to this IIoT system would be obviously the data gathered by these systems. The devices, which are your smart sensors, actuators, and maybe other end devices, right? And what is your goal? What is your output? Your output is to enhance your manufacturing and industrial processes. Okay, so you can see where your interest lies. So when you talk about Internet of Things, you can aim different types of goals, but here your output should be addressing your goal, which is to enhance a manufacturing and industrial process. Okay, and as I mentioned in the previous slide, if I enhance my manufacturing and industrial processes using the data collected by smart sensors and actuators, that is what leads to my Industry 4.0. Okay, so IIoT and Industry 4.0, these are like very connected terms. Okay, IIoT is the technology which is going to thrust or thrive Industry 4.0, and the main idea basically of IIoT or the Industry 4.0 revolution is to make smart machines. Okay, and this smart is a word that you're going to hear very frequently throughout this workshop, right? What do I mean by smart, right? Forget about machines. In general, when I say someone is smart, what do I mean? Right? By smart, I mean, if I say someone is smart, technically, like more often what we say is that person knows his or her job, right? He or she knows what to do, right? Exactly, that is the idea. When you use this prefix of smart with anything, that's what you intend to mean. When I say smart machines, what I mean is machine knows his business. Machine knows the business that it needs to do. Machine needs to know what is need to do. It does not need a person or human to tell it what to do. Okay, that's the idea of making it smart. Now, how do you do that? How do you make machine understand what to do, right? Those are the ideas which IIoT mentions. Okay, so the idea of IIoT is to make your machines smart. That means they should be able to take decisions on their own. Obviously, it will not be completely on their own, but majority of them. And they should be able to analyze the data so that they can make benefit of it. Okay, over the period of talk, we'll see what are those benefits, but this is the idea. Your idea is to boost your production in your industrial sector by making your dumb machines smart. Okay, and I already told you what I mean by the notion of smartness is they should be able to do decisions on their own. Okay, so what does it boil to? What does this boil to of the idea of IoT using smart sensors enhancing manufacturing? The prime idea that it boils down to is the devices, or whether it's sensors or if there are any end devices, they should be able to communicate with each other. Okay, devices should be able to work on their own with each other, okay, without human intervention, which we normally call as machine to machine communication. So if you just go back to the first slide, you can see how we are back in the same domain. If you recall, when I said Internet of Things, we are trying to connect things in a way the internet is connected. Okay, internet earlier was connecting people, but now we want internet to connect things. You can see the notion being carried out here. What we want is, like people communicate over internet, devices should also be able to communicate and direct each other. Okay, and again, as I already mentioned, the goal is obviously this, that you want to reduce human intervention to the least extent possible. And I already gave you the reasons why. Because you want to increase your throughput, remove this bottleneck. Right? So that's the idea of Internet of Things, making devices communicate with each other, obviously, but the goal is the enhancement of manufacturing and industrial processes. Right? So before I go down some more details of this, now we saw that what IIoT is eventually doing is making our dumb machines smart, right? Now, when I say making dumb machines smart, what aspects do I mean by the smartness? Okay, because smart machines is like the core, the heart of your IIoT. So when I say smartness, I already told you the notion of smartness means to be ability to do things on your own, right? Now, what does it technically boil down to? Okay, when I say machines will do things on our own, but what do I mean in technical terms? In technical terms, what I mean is smart machines should be better than humans who earlier were operating them in capturing and analyzing data. Okay, so earlier when we had dumb machines, when we were manually operating them, that time, if you compare the scenario of that situation with the present situation where we are going to make these smart machines, they should be able to capture and analyze data in real time. Okay, so humans, they don't take decisions in real time, right? They have to first capture all data, then they will apply some analytic techniques, and then they will perform it. What is our goal here? To use the smart machines for, they should be doing all this in jiffy. In real time, they should be capturing data, analyzing, looking at the trends, and giving us some solution to enhance our production process, right? And the second thing is, where smart machines need to outdo or be better than the human counterparts is communicating. So if humans, assuming they have captured and analyzed data, and they are sending the data, okay, the rate at which the communication is occurring, this should also be very immensely improved. Okay, by immensely improved, I mean, if machines have analyzed and captured data in real time and they immediately communicate it to some data center or where some business decisions need to be taken, that's where our productivity increases. Okay, so you can see from both these points, what is the goal? The goal is to reduce the latency in analyzing data and making decisions. Okay, and if you do that, obviously your production is going to increase, right? That is like the core idea behind IIoT of using smart machines. What is the idea? The idea is to understand, the capture and analyze data in real time, and then after you have analyzed data and you have come to some conclusions, communicate it at the right time to make the right decisions. Okay, so this is where basically IIoT lies in. Okay, now those of you who might already have a good idea of IoT, which I'm sure from workshop you might have already gathered, you might be thinking then, what is the difference between simple IoT and industrial IoT? Okay, so let's try to see the difference from this slide. So when I talk about simple IoT, what I'm normally talking about is the broader domain. Okay, IIoT comes a part of it. Okay, normal applications, when we talk about normal IoT, that is sometimes also called consumer IoT. Okay, But what we are interested here in this talk is industrial IoT. Okay, so you can see on what basis am I splitting industrial IoT and consumer IoT, right? The difference is in the basis of application area, where I am applying IoT for. You can see if you look at this side of the image, if you just partition this image into two, okay, if you look at this side, all the applications there are restricted to a particular consumer. Okay, you can see this first sector. This is more of a personal level IoT. You know, the wearables you have, your smart shoes, your smart home setup, and all of that. Okay, it's catering to a particular person, individuality of a person. You know, smart watches, smart shoes, maybe your mobile phone, your tab, and etc. And the second thing you can see is like a home automation setup. You know, you have home monitoring, home automation, your appliances are connected and all. So you can see the focus of this side of IoT applications is on more of on consumer, right? But when we come to industrial IoT, the idea is still same. Objects are going to have some form of sensors and, you know, actuators attached on them, and they are going to exchange data. Idea is still same, you know, because your backbone technique is same. It's still IoT. But what makes it different from it is its application domain, right? Its application domain is on the industry. You're focusing more on industry, like transportation, smart cities, factories, healthcare, the industrial aspect of it, not on the individual aspect of it, right? So that basically summarizes our IIoT versus IoT. Okay, IoT extended to the setup of industry is your industrial IoT, right? And that's where the difference lies. Otherwise, if you look at the common things, both of them are going to be supported by some form of network, cloud connectivity, right? So there are a lot of common things, but what makes them different is their application domain, where they are applied, where they are going to be used for. Okay. So that is IIoT versus IoT. Now, the idea is, how does IIoT work? Okay, what are the main components of an IoT architecture or an IoT ecosystem? Okay, so let me directly jump to the diagram to explain it. So in general, in any IIoT architecture, mostly comprises of 4 layers. Okay, so you have something called a device layer. Okay, then next you have a network layer. Next you have basically a application layer, which can include services as well as content. Okay, so services layer and content layer. So let's see each one of them one by one. So if you look at the first layer, which is your device layer, okay, what does device layer consist of? Device layer will consist of all your end devices, okay, your input, the source of your input. Where does your IIoT setup get the data from? That is your device layer. The end devices which are going to generate data for you, right? Like if you consider a smart city example of Industry 4.0, a smart city example of IIoT. So the end devices operating on traffic lights, on street lights, on cars, on vehicles, all the gathered data from that represents your device layer. Okay, so you can see device layer is more of like your input, the input to your IIoT. Okay, then is your connectivity layer. Now all these devices have unique IDs. They are going to gather data for you. But as we know, the sense of IoT lies in connectivity also. Now, how do you connect all these devices together? Right? That is the concept of network layer. Okay, there are different network protocols or techniques which are functional. You know, there is Wi-Fi, there is Bluetooth, there is Zigbee, there is long range, there is narrow band IoT, software defined networking, network function virtualization. All of these are there. As I mentioned in the beginning itself, I'm not going to go into technical definitions. That's not goal of my presentation. But just to give you an overall picture, this is important aspect, because what you're going to have is you have a device layer and you will have some more higher layers. The connectivity between the two, the connectivity part of this is going to be the job of this network layer, okay, to enable connectivity between different devices so that they can communicate with each other. right? Now coming to the third layer. Okay, the third layer is, now once everything is networked together, everything is able to somehow exchange data, what do you do? What do you do to that? Your gateway collects that data, everything is there. What do you use it for? Okay, there are different platforms, different applications where you can use it. You can use it for analytic purposes, getting trends from data and taking some decision. You can use other assistive technologies like machine learning, AI, fog, edge computing to get to some decisions and make some decisions. Okay, what kind of decisions you can make? You can manage devices in IIoT. You can perform machine to machine communication, one device in directing other, etc., etc. So all these underlying techniques support your various functionalities, various use cases of different applications of IIoT. Okay. Now, if I come to the applications, okay, so these applications will be visible at what we call UI, our user interface, right? The final place where our decisions will be visible. Okay, so you can visualize the impact that you gather data and apply different techniques on. Their impact you can visualize using the output layer or your user interface. Okay, what could it be used for? It could be used for, suppose you are working in industry and you want to see whether your different kinds of machines are working properly or not, whether they are safe for the people who are within the factory or not. If some part of my industry, some assembly line requires some, recovery, or there's some fault there, I need to isolate that fault, I need to correct that. Okay, whether the condition of my assembly line is good or not. Okay, we'll see all these applications specifically when we come to the application area. But this is the overall picture. You have device layer, which gives you input. At the top, you have application layer, which is the user interface where the decisions will be reflected. And in between, you have a network layer, which ensures connectivity between all the devices. And the gathered data can be applied, different analytical techniques can be applied on that so that you get trends out of it and make decisions, right? So this is overall how an IIoT architecture is in place and how it works. Okay, any questions till this point?
If you have any question, you can unmute or post in the chat box. I think there are no questions.
I think we are studying smart devices, but we have dumb audience. So please have questions. That's what will make this talk interactive. Okay, so moving ahead, in case there are no questions. So question comes now next. Why is IIoT beneficial? You know, we already have such good industries. They're already producing so much good output, throughput every day. You know, if you look at any sort of industries, whether it's automobile, it's oil, gas, it's currently vaccine industry, supply chain, everything is going on so efficiently. What is extra that is IIoT going to give us? Okay, so let's just kind of summarize it. First major impact of IIoT is going to be predictive maintenance. Okay, what do I mean by predictive maintenance? Okay, I'll explain it with the help of an example. So suppose I consider an industry, okay, a factory where I have different kinds of, suppose an automobile factory for example. So I have different assembly lines which are assembling various components of an automobile. Okay, now if I run that factory as an IIoT use case, that means I'm going to deploy sensors on various assembly lines, on various components. What I'm going to do is this network of all these sensors on different components of the assembly line are going to keep track of all the assembly line units. Okay, at any point of time, if any machine undergoes any fatigue, you know, if it's at a very prime stage, if I was in a older era, industry 3.0, then till that fatigue kind of materialized and some human who or worker identified that fatigue, till that point you had no clue that your machine was about to break. You know, until the point a break point comes and the machine is broken, your factory is down, you are not able to know that there was some small fatigue. But now assume that you have these sensors deployed at all the points of your factory, and you have the sensor readings coming continuously, giving the idea of what is the fatigue, machine fatigue at different points of time. And as soon as your IoT network detects some abnormal trend, it can alert the desired authorities that at this point of time there's a slight fatigue developing. Please keep this in mind, right? So that is what we call as predictive maintenance. What you are doing, because you are tracking and keeping track of everything continuously and automated. Okay, you can gather data, it's continuously being analyzed. You like for this fatigue case, the at the decision center it would be known what is the threshold when you should declare that it's an emergency or something, right? So you're automatically making a decision whether to carry forward this message forward or not. So what you are actually aiming to do is prevent random failures, because you're not expecting any random failure because you have been tracking all the objects at continuously. Okay, and if there are no random failures, there you are keeping track of the entire assembly line continuously, there will be no unplanned downtimes. You know, there will be no times when your factory will be down and you don't know what to do about it, right? So predictive maintenance basically means maintaining your factory or industrial setup in a predictive manner. That means before the actual loss occurs, you continuously assess the situation so that you can prevent such downtimes. The second aspect of it is the enhanced field service. What we need is, because IIoT is not just about connecting devices, we are also going to connect the information gathered from devices with our service people. You know, every industry, especially those industries which have a very huge demand in terms of the products or in terms of the it's catering to a large number of audience. There we can connect the data gathered from your IIoT setup to our field executives so that they can have an enhanced field service. So you can mobilize your people immediately if they require tracking. So your quick, seamless troubleshooting with a better connectivity. You know, it's like sometimes you require a better man force or for workforce to come to a particular place. You can connect them as well, because it's not just about connecting things. The data connected or collected from the things can also be passed on to the people who are handling it, right? So enhanced field service is yet another category or benefit that IIoT provides. The next is energy management. Okay, but by energy management, what I mean, I use smart meters. Okay, by smart meters, I mean we know when, even at homes, like currently we are suffering in Srinagar so many power outages, right? Because our power department is not able to handle the load. Okay, by smart meters, we mean that meters who know what is the demand, and that's how they'll manage the energy requirement on that. Okay, now if your factory is just a day factory, then there's no sense of using the same amount of wattage whatever you take during the night, because that time your factory is down, right? Using meters smartly based on your need is what we say is IIoT's benefit of energy management. Okay, because you keep on gathering data, which machine requires more energy, and accordingly you can give your demand for energy and reduce your bills. The last part about the IIoT, the major benefit that IIoT can bring in is asset tracking. Okay, by asset tracking, I mean different components are going to be on radar. You're going to track all of them. Okay, so nobody can counterfeit them. Okay, so like if I have a huge assembly line and suppose I am manufacturing steering wheels for an automobile, nobody can change a steering wheel with some counterfeit product, because throughout the supply chain you're going to keep a track of it. Okay, so for better accountability, IIoT is the key idea, right? So there are plethora of industries which have, you know, which can have use cases for IIoT. Can be robotics, smart grid, smart power, smart car, and so on. I'm going to discuss some of them one by one. So let's come to automotive industry, or what we say automobile industry. In automobile industry, already a lot of industries have picked it up. Okay, specifically if I talk about a specific use case of Airbus, so they have already started something called future industry, which is more or less already in an IIoT setup. Okay, what are they doing? Basically, the entire assembly line, which is dependent on each other, is based on industrial robots. Okay, they are proactively keeping the track of assembly line, assembling everything, and any issue in the production Only that is notified to the human workforce. Other than that, everything is already automated. Agriculture industry is another major industry where IIoT can be useful. Okay, so like 4 main subdomains where IIoT can be useful in agriculture is precision agriculture, agriculture drone, livestock monitoring, and smart greenhouse. Okay, so what is this all about? Again, I'm using some specific terms: precision agriculture, agriculture drone. Let me give you an overall idea what I mean by use of IIoT in agriculture industry. So what we are going to do, suppose we have a piece of land where we are going to do some form of farming. So we drop some sensors there. Okay, what are the sensors going to gather? They're going to gather all sorts of data. What is the soil condition, the nutrients, moisture, etc., etc. So now once you know what your soil requires, what is the current condition there, then based on that, you can very tactically, strategically decide what amount of fertilizer do you require. You know, if your soil is already very rich in sodium, why do you want to put sodium again, right? That is actually the key idea about precision agriculture. Precision word is here used to give in the resources as per the demand, very precise amount of resources. Basically, precision agriculture is more of about what is your demand. Based on that demand, you take a decision and you do your agriculture according to it. Okay, just to give you an overall idea, as I gave you an example, like if suppose based on the gathered data from my sensors, I get to know that my soil is weak in something, and what I want to grow some crop is that nutrient is more important. So I need to know, I need to add that fertilizer into my soil, right? Now, what should be the quantity? Okay. Now, one way is to do it manually, but to automate all of this is what we call as precision agriculture. How will you make that decision? Based on the gathered data from all your sensors. Similarly, it's agriculture drone. Like if you want to spray your pesticide or any sort of extra things on your crop and you don't want to do it manually, you want to do it via drone. You need to tell drone which areas you want to push in, right? That can be connected with sensors. Those areas which lag in certain quantities, you can feed into the data so that a decision can be taken by drone to drop in more quantity there and less at some other place. Similarly, if you want to keep track of your livestock, okay, so this is something which has already been done. You have already of the extinct and endangered species, you already, specifically for endangered species, you already have RFID global tags in place, okay? But here we are talking about a normal farmland. Like if you have livestock in your agriculture land, you want to keep track of them, where are they going, or what kind of food are they intaking and all, you can do that as well. Right, and then greenhouse, making it smart means providing it the desired conditions based on the data gathered. So all this you can see different aspects of it. The underlying principle is same. You're gathering data in real time, okay, and that gathered data is helping you to make some decision, right? Similarly, you have oil and gas industry. In oil and gas industry, this again is a very popular use case of IIoT where people are picking up this quickly. And the reason being that there was some statistics by some of the people surveys where it was said that majority of the fires that are caused in all these huge oil and gas industries, they come because of pipeline leakages. Okay, and pipelines are spread over huge lines, right? How do you manually detect that? Okay, that's where IIoT comes to picture. In IIoT, you can have sensors deployed at regular intervals. You can have autonomous vehicles like drones and other UAVs keeping a continuous track of your pipeline setup. And as and when you have a slight iota of doubt that some pipeline is under, some fatigue or some defect, it's going to, make the audience or the desired decision makers aware of that problem, and they can quickly correct that defect. Okay, so pipeline leakage or pipeline defects is main motivation why oil and gas industries are shifting to it, because a massive amount of loss is yearly accounted to such accidents. Then of course is your supply chain, food supply chain. And by supply chain, I mean, if you look at any food product, okay, like if I suppose consider like our Lay's Uncle Chips, okay, they have a huge supply chain. Okay, it starts from the potatoes that are gathered in farm all the way till they are moved to the factory, they are trimmed off, and you add all those spices, you package the food. So if you look at all the different components, the different stages of supply chain that they go through, if you don't keep track of all these steps, you have chances of having counterfeiting, or you have chances of having things which may not be of good quality, right? So all sorts of ensuring product quality is something which IIoT can bring in. But apart from that, there are different other aspects that if you embed your sensors into your supply chain or your food industry, that can help you. Like, you can get best use of your logistics. Like, if you have a cold house, or you have a warehouse for maintaining a cold supply chain, you'll have if your entire supply chain is coordinated, you'll have an idea where you have exact space, where you can keep it. And as a result, if you want to maintain a cold chain, they'll not go waste. Okay, I can quote an example here. Recently in Brazil, there was a, I don't know, millions of loss of vaccine, which is currently so much in demand in all sorts of countries. So that was a huge loss, because normally if we incur any loss, that's not very important. But currently everyone is in need of vaccine, and having a loss of some 1 million doses was huge. Okay, and that failure occurred because the cold house where they were supposed to maintain the cold chain for that vaccine, that was already booked. So there was a mismatch in the supply chain department. So if you had IIoT in the place, that would never have occurred, because IIoT would have kept track of all these components and tell you where your occupancies lie, right? That is what we call as smart warehousing. You know where your logistics are going to be handled. So all these industries, are like major use cases where IIoT can be used. This slide, I'll not go into details. This is self-explanatory. You can see what percentage of industries are currently using the IIoT setup. You can see it's more of dominated by industrial products and electronics, but nonetheless, consulting, pharma, food, beverages, retail, and all are also picking up on using IIoT. Okay, so that was all about IIoT and what are the major industries which are using IIoT. Now, with every new technology come the associated risks and challenges. Okay, so this is more important topic because of the audience. Okay, we all here as faculty members, we are at some point researchers. This is where our gaps come in, right? What are the places where we can make our contribution other than implementation? So the first major risk that IIoT poses is in terms of security, right? Now, what do we cover in security? So first common security issue which arises is when we produce these IIoT devices. Okay, normally they are kind of configured with very default passwords, and many people, because of whatever reasons of being lazy or anything, don't change it. Okay, so there's like those of you who had a geofiber connection, when we connect a geofiber connection, it's always connected by some default username and password. Okay, and if you have been lazy, you have not changed it, so anyone can spoof into your network and access or use your network. Same problem happens in IoT devices. Most of the time, what ends up happening is even the devices, when they go into production phase, their default things are not changed, which makes them vulnerable, right? The second thing is most of the IoT devices transmit data as clear text. Okay, and you can see where the loop lies. Clear text is clearly a big hole, big gap where any attacker, any invader can enter through to your network. Okay, clear text can easily be read by any third party. So definitely that's a place where we need to work on. Okay, so similarly, whether it is this default setup issue or the issue of sending data as clear text, your IIoT devices currently are very insecure, right? Now, if your IIoT device is insecure, anybody can, take over them. Then they can become platforms for launching attacks on network resources. Okay, what I specifically mean, these IIoT devices, some malicious user can use them for carrying out denial of service attack or DDoS attack. Okay, because of the ability to overcome it. Okay, so security is a big aspect where in general a lot of people are already working, and in IIoT setup also that would be important, because our application domain is industries, where any manipulation of any device could be very risky and could have a huge impact on our end result, the manufacturing throughput. So security of these devices is super important. The next issue or the challenge which we face in the IIoT is the device management. Since in IIoT we are going to use so many devices are being connected, so having like millions of devices connected together also increases the management issues. Okay, how do you identify which are valid devices to a network? How do you identify which are invalid one? Okay, somebody might say that we have unique IDs, so why can't we identify? People can spoof your identity. How do you handle that part? Okay, if suppose you have a network of devices and some device fails, how do you perform quick replacement of that device? Okay, and similarly, patch management. So patch management is more of important in industrial setup, because suppose we have different devices implanted into our industrial setup which use different kinds of firmware, right? Your firmwares can it's not like it's once and for all. I have a firmware installed in 2021 and I expect that it will be running until 2031. That's not possible. I'm going to get updates. Market is changing continuously, right? How do I get those patches? And if you're not here talking about 100 devices, we are talking in millions. Okay, how do you manage that part, right? So basically handling the scalability that you have achieved using IIoT, how do you handle that part? That's another major challenge that researchers are trying to tackle in this field. Okay. Now the big dollar question, like, is IIoT already in market? Do we already have places, industries which use IIoT? And the answer is yes. I'm not going to go through these examples, but you can see the names are already there. You have already companies in automotive manufacturing, you have companies already in networking venture who are already using IIoT for their better production. You have Cisco IoT, you have Exxon, you have Aviva, you have Fonk, Lynx, Mindsphere, Platin. All these markets are already in marketplace. They have already started using industrial IoT and they are already getting benefits of it. Okay, so it's not something a proposed technology, it's already in place. There are already platforms which support this, which provide you consultancy services for this, already in market. Okay, so that is basically the first part of talk, which was IIoT. Okay, I already did a lot of time there. So, Jhangi, any questions till this point? So I assume there are no questions. So I'll move to the second part of the talk, which is 5G. So again, I'm sure 5G has been covered in other talks. So I'll just give a very brief idea of what is 5G all about. So 5G, as we all know, wireless communication has also developed. Like industrial revolution, wireless communication has also evolved over the years. Okay, we started with 1G, 2G, 3G, 4G, and we have moved to 5G, and now people are also talking about 6G, right? But what we are interested here is 5G. What is 5G? Is the fifth generation of mobile wireless communication. And what makes it different? What makes it different is a promise of giving you a faster data throughput and low latency. Okay, and there are certain other promises that it's going to give you. It's going to be energy efficient, at least 90%. It's going to be almost 100% reliable. It's going to give you a huge connectivity, 500 km per hour. It's going to ensure your latency is below milliseconds. Okay, so with all these features, you have your 5G, right? And in terms of services, there are three basic categories of services which 5G provides. First is your enhanced mobile broadband, which basically covers all these applications, broadcasting, your applications like virtual reality and all. Then you have massive machine-to-machine type communication, which is used in applications like smart building, logistics, etc. And last is ultra-reliable low latency communication, which again has these use cases. So we'll specifically see this once again when we come to IoT. Now, the question is 5G, okay, is giving you promise of high throughput, high data rate, low latency, efficient, reliability, then how 5G is going to impact IIoT. Okay, so where is the role of 5G in IIoT? That's the question we tackle next. As we know, 5G came with the idea of promising you high throughput and low latency. Okay, and if you recall from some of our earlier slides on IIoT, we had discussed that what we require in IIoT, when we say that we have a smart machine, what we require is it should be able to gather data in real time and make some decisions in real time, right? Earlier, before 5G, you could ensure very high speed connectivity only in private networks. It was not available on such a wide scale. Okay, so that is where the first and major role of 5G comes into the picture. That is, it will provide you with high throughput and low latency so that your sensors and all these devices connected can be sharing data in real time. That's the first major thing. Second thing, which is quite related to it, is device proliferation. If you look at the industrial operations, if we don't have 5G, we are still stuck on 3G, 4G, where access to remote sites is still inaccessible. Then doing industrial operations there with IoT is impossible. So if your IoT gives you a wider spread coverage, then you are expected to reach those remote sites as well. Okay. Third implication of where 5G can be useful is the three-tier service that it provides. You know, the enhanced mobile broadband, which gives you high throughput, the ultra reliable low latency communication, which gives you low latency, and your massive machine type communication, which gives you a wider coverage. All these three aspects can be very much utilized by our IIoT. Okay, and we'll see a use case at the end to justify that. Okay, so what is the use or why or how 5G is going to help IIoT? The first thing is your connectivity part. Okay, it's going to establish connectivity at a much larger scale. Second is it's going to give you a real-time sharing of data at a very high speed and with very low latency. Okay. Now, I like to conclude my presentation or this talk with a use case of a 5G based smart manufacturing. Okay, so you can see I have both the components involved in this use case. So this is a smart manufacturing plant. Okay, and that means it is actually a IIoT environment. Okay, and what I'm going to do, I'm not just using IIoT alone. I'm going to support it by a 5G network system. That means I can share data at high rate, at low latency, and very quickly. Okay. Now let's try to see this diagram. So you can see this is your device layer here. Okay. This is your connectivity part, the network layer. And this is where, you know, your application layer, where you are going to perform all sorts of decisions. Right? Now, if you look at the device layer, okay, it has been categorized very specifically into the three types of services which are provided by 5G. Okay, if you recall, MMTC, massive machine type communication, URLLC, ultra reliable low latency communication, and EMBB, which is your enhanced mobile broadband. So you can see all three kinds of things can be used in a manufacturing unit. Like if you look at massive machine type communication, you can see how you can identify various locations of your production unit using MMTC. You know, you can have sensors deployed at different parts of your assembly line in your industry unit. You can gather data in real time, send it to some data center, and forward it to your cloud. Similarly, if you look at ultra reliable low latency communication, what are the situations where this would be required? Okay, if you look at an assembly line where one unit is related to other, okay, you cannot there expect any sort of delay from one unit to other, because if there's any delay, the dependency will make the entire factory useless. So all the applications where you expect no latency, there you can use this service. Right. Similarly, the enhanced mobile broadband. So what you can have is, suppose you have a manufacturing plant which has different floors, and different floors have different manufacturing things going on. How do you and you want to broadcast some information throughout the factory unit? Okay, there you can make use of this EMBB service. Okay, now from all this device layer, ultimately what you are gathering is just data. Okay, and you are exchanging or having the exchange of all sort of that data using the network layer. And then once network layer has collected and internet worked all these devices together, you can take the actions. Okay, you can go for some servicing, you can go for planning or scheduling your plant accordingly, you can have your smart energy monitoring, all different kinds of requirements that you can cater to for a manufacturing plant. You can make those decisions based on the gathered data from your end devices and the analysis that has been done by the intermediate layers. Okay, so you can see how IIoT can be combined with 5G to give you a enhanced productivity. Okay, so that's it for my presentation. So I'd like to conclude. I won't conclude with normal conclusion, like giving a summary of what I already studied and again repeating the same stuff. But what I would like to conclude is to summarize the goal with which I had started this talk. Okay, if you recall, what was the goal of the talk is to make you aware where you can, what is IIoT and can you implement this IIoT setup in your local industries. Okay, so that is where I will end my this question. How is IIoT relevant to us? Okay, now as an audience, why are you are in this workshop attending this? First question every time should come to your mind: if I'm attending a session, why is it important to me? Okay, first thing is obviously your understanding about IoT. That's fine. And obviously, if IoT is implemented in industry, we know that industrial revolution has always had a direct correlation with society. If industries have evolved, the quality of life has improved. Okay, that way also it's important. Okay, but what else do we have in here? Okay, I assume all of you are faculty members in different institutes, right? And at some point of time, you are also involved in research, right? So that is again another venture where this IIoT is relevant. Okay, what is the idea of IIoT there? The idea of IIoT is all of us as researchers can have, we can collaborate with our industry partners. Wherever local places you live in, you can see what are your local industries. You can collaborate with them, help to implement an IIoT environment for them so that their productivity can be boosted. That's like the one aspect. The second aspect is the research gaps that I mentioned in the talk. Okay, there are a lot of places where we require an improvement, where we require the active participation of researchers to tell us how to solve those problems. Okay, that is where your role can come in. You can help us contribute to that and help us to make IIoT actually achieve the aim that it was actually built for. Right, the industrial revolution of 4.0 was built to enhance the productivity to extremely high levels, which we have never been achieved so far, by reducing the human intervention. Right, so that's where our goal lies. Okay, so that's it for my presentation. Thank you very much for listening, and I'd be happy to take any questions. Any questions?
I think there are no questions.
All right.
So, thank you, Dr. Iqra.
Thank you so much.
Thank you so much.
Thank you, ma'am.
I request everyone once again, we have one more session, and that session is somehow important for all of you. So please at least be